This conference will now be recorded.
Okay, then. Hello, everyone. Good morning, good afternoon, and good evening to everyone, wherever you are. Romy, can you confirm that I am audible to everyone?
Yes, you are audible to
Okay,
us.
thank you. Uh,
Yes, you are audible.
Thank you.
Yes.
Hello, once
you're
again. Good morning, good afternoon, and good evening to everyone, wherever you are. First of all, thank you so much for attending this online session in Introduction to Oracle Cloud Infrastructure by Rohit Rahi. And on behalf of Nepal Oracle User Group, I would like to thank Rohit a lot for accepting our invitation. And this is going to be a very valuable session because this is a cloud era, right? Uh, Oracle has recently offered OCI free training and certifications. And if you have enrolled for it, then you have heard about Rohit and his videos. Rohit is a senior director at Oracle, leading technology enablement and solution architect at Oracle Cloud Infrastructure. Last year, I successfully completed my OCI Architect Associate 2018 exam with the help of video made by Rohit. And right now, I'm again watching Rohit's video to upgrade my Architect Associate exam to 2019. And thank you so much, Rohit, for such a nice and helpful videos. Actually, I am not trying to please him, but I'm a big fan of the way he explains. The video sessions are so smooth and it contains a lot of detailed information. And thank you once again for these videos. As usual, I would like to humbly request everyone to stay mute until the end of the session, and you may raise your question by text in the chat section anytime, and we will grab them and reply at the end of the Q&A during the Q&A. Yeah, in the same way, I request everyone to fill up the feedback form. We'll post feedback form URL in the chat window. And now, without further ado, I would like to hand over control to Rohit. Rohit will start with his introduction and exciting session. Okay, let's hand over session control to Rohit. Okay, Rohit, I have made you a presenter and all yours.
Hey guys, can you hear me?
Yep, we can.
Okay, fantastic. Let me know when you want me to get started.
Rohit, you can start it right now.
Okay, fantastic. So thank you everyone for your time. I am assuming that most of the people who are joining are from Nepal. Is that true or?
We have few people from Nepal, few people from India, and most of all over the basically it's from the all over the world.
Okay, fantastic. So morning everyone. I think mostly would be morning for you guys, 8 o'clock. So thank you for rising and shining in the morning. and going through this hour-long webinar on Introduction to Oracle Cloud Infrastructure. Thanks, Roman, for inviting me. My name is Rohit Rahi, and I'm a Senior Director working for Oracle Cloud Infrastructure in Seattle. Before I get started, I just want to say, hopefully all of you are staying home, staying safe, taking care of yourself and your family. This is a difficult time, so just keep the social distancing and just follow the guidelines which your governments are asking for. So I just want to start with that. Next 45 minutes, what I'm going to do is I'm going to walk you through Oracle Cloud Infrastructure, what it is, and give you some ideas as to what the key services are. Of course, something like this to cover in 45 minutes, an hour is to squeeze a lot of content. So I will try to stay at a high level, but just still give you a good overview of Oracle Cloud Infrastructure. And also for people who are interested, I don't have a slide, but we have made all our certifications free till 15th May. So the content is all free. The certification is free. You don't have to pay anything for the exam. So I would highly recommend you guys to go and take that. I'll show you once I complete my presentation. I'll show you how to go and set up your account and get the exams for free. Well, before that, let's quickly go through some of the core concepts. The way this presentation I have divided is the first few. Just let me get my pen to work here. Okay, all right. So the first few topics I'm going to cover are related to the infrastructure. So we'll talk about all right, anyway, it doesn't matter. So the first few topics I'm going to talk about are related to infrastructure, and then we'll talk about some of the core services. All right, doesn't seem to work. Um, so we'll look into OCI regions, availability domains, fault domains, what these are. We'll look into how you can design highly available application. We'll look into compartments, what these are. These are core concepts for Oracle Cloud Infrastructure. Then we'll look at the core services, the set of core services, right? Networking, compute, storage, database, identity, and access management. And these are some of the core services, whether you are using Azure, you're using AWS, you're using Google Cloud, or you're using Oracle Cloud Infrastructure, right? You would see the same kind of concepts in every cloud provider. So I'm going to cover those. And of course, today, OCI has something like 50 or more than 50 services. So the idea being, this is just your introduction to OCI. It is the first time maybe you are listening about Oracle Cloud Infrastructure. So just to give you an overview of what core services look like. And of course, you can go and read more on the documentation, and there are training videos, etc., which you can look at. Just give me one time. I take a lot of notes and like go on the screen. So for some reason it doesn't work. All right, just give me 1 second. Let me try to open this file again. Let's see if it is. All right, doesn't seem to work today. That's okay. So let's talk about some of these concepts a little bit more. So the first idea is today we have 21 regions live, and there are 15 more planned. for the remainder of this year. Now, this, as you can see here, this is from February 2020. Things have changed since because of COVID-19. So some of these regions might get delayed in when we launch them. This was our original plan to launch all these regions by end of this year. But with the situation of COVID-19, some things might change. But you can see some of the commercial regions where we are live, some of these regions which are planned, some of the government regions, and then we also have this interconnect with Microsoft where we connect an Oracle region to a Microsoft Azure region. So you can see some of those regions listed out here, right? And we are constantly adding more regions. So the takeaway from this slide is that, look, we have a global footprint. Why do we have a global footprint? Well, we want to you to
Rohit,
be
Rohit, sorry to interrupt, but we are not able to see here. Uh, Actually, it's a black window we are seeing in the PowerPoint.
okay. Hang on 1 second. Let me give me 1 second. Okay, let me know when you guys can see it.
Yeah, it's better now.
You can see now?
Yeah.
Yes.
Okay, fantastic. So
Yeah,
the
Rohit.
idea, yeah, go ahead. All right, I'm assuming you guys can see it now, right?
Yes, yes.
Okay, fantastic. So, the idea being we have a global footprint and we want your applications and you to be closer to your users. So that is why you see us, having regions worldwide. This is again common phenomena. Every cloud provider does it, right? So we are trying to get there as well. Now, a few things to keep in mind, right? As you are designing your applications, these what are the core considerations? So for region for us is a localized geographic area which is comprised of one or more data centers, which we call availability domains. Availability domain itself is one or more fault tolerant isolated data center located within a region but connected to each other by a low latency high bandwidth network. So you can see here there's a region and there are three availability domains within these regions. Now availability domain itself is completely fault tolerant, completely independent of other regions. So you can think about these as completely isolated data centers. Sometimes these are also clusters of data centers, so not just one data center necessarily. And then within availability domain, if you zoom in, there is a concept of a fault domain. What we do for fault domain is it's basically a grouping of hardware and infrastructure within an availability domain to provide anti-affinity. What it means is you could create your applications across two fault domains so that at any given time, if even if one fault domain is unavailable, your other fault domain is still up and running. So there is a concept called a logical data center, not a physical data center, because this is all one data center. But within that data center, physical, you take that and then you slice it into three different logical data centers, right? What does that mean? Well, before we go into that, right, some of the new regions we are launching are going to have only one availability domains. Now, why are we doing that? We are doing that to optimize for speed versus optimizing for efficiency. Because we cannot launch, 21 regions in 1 year if we have to fully build out three data centers and so on and so forth, right? Look at Google. They do that every region they have three data center zones. It takes time, right? Because you have to build out, you have to sign contracts. It takes time, right? So for us to optimize for speed, we are building these one AD availability domain regions. And if you look at our map today worldwide, we started with North America. So you see in US we have two regions, they have three ADs. Europe, actually we also had three ADs, but everything else subsequently we launched had only one AD, whether it's for Germany, Australia, India, Brazil, Middle East, whatnot, right? One AD. Now you might be wondering sitting there is, okay, if I get one AD, how do I design for high availability? like how do I go about that? I'll cover that, right? But first, let's talk about how do you choose a region. Well, you choose a region closest to your users. Why? Very simple. You want lower latency and highest performance, right? So if your users are, let's say, in India, your likelihood of running an app in North America is lower, right? Because your traffic is going all over the Atlantic Ocean, and you have to, the latency will be higher compared to, if your application is running, let's say, in Mumbai. Um, there's also data residency and compliance issues. Many countries want the data to not leave their geographical borders, so you have to, comply with the local laws and regulations. And then also, this is again common with every cloud provider. Services are not available in every region, and when we launch services, we roll them uh, based on various considerations, and sometimes a service might appear in a region before other regions, right? So also that is consideration. Now, as we talked about, availability domains are logical data centers. They are completely isolated from each other. They are unlikely to fail at the same time simultaneously, and they don't share physical infrastructure such as power, cooling, or internal network. So if a failure happens in one availability domain, it doesn't really impact the other availability domains, or it should not impact. Now, there are considerations where there's a natural disaster. Let's say there's an earthquake or flooding or something. It's possible all three availability domains in a region become unavailable simultaneously. It's possible, but typically those are very rare. Those kind of natural disasters. So this is what the graphic is showing here. If there is a natural disaster in availability domain 1, your availability domain 2 and 3 are still up and running. So you design your applications and you distribute them across these ADs. So even if one AD is unavailable uh, or fails, your other two ADs are running, your application is up and running. This is very common. Every cloud provider has this design, right? And we have something similar. Now, you might have noticed that I said that the new data centers or the new regions only have one availability domain. So if that is the case, how are we going to create highly available designs? Well, that's the place where fault domains come in, right? Each availability domain has 3 fault domains always, not more than 3, not less than 3. A fault domain acts as a logical data center. I have put this in bold, logical, meaning it's not physical, because of course you have availability domain which is physical. So you take that and then you slice it into 3 different parts. Think about this as you have a building, you slice it into 3 different areas. And the idea is these fault domains don't fail at the same time, or at least not supposed to fail at the same time. So what do we do to make that happen? They don't share single points of hardware. So things like same physical server, same physical rack, top of rack switches, power distribution units, cooling units, those are all kept separately. So even if something like a top of rack switch fails for a certain rack in a fault domain, the other 2 fault domains will not share that top of rack. So the idea being, if we take the previous picture, every availability domain has 3 fault domains, as you can see here, not more, not less. If one fault domain is unavailable within an AD, the other 2 fault domains are still up and running. So you can distribute your applications and you can create your applications to leverage this hardware capability or this infrastructure capability. Now, how do we do that? How do we design highly available applications? Well, see, if you have a region which has more than one availability domain, it's actually pretty straightforward. This is what Google does, Amazon does, Azure in regions where they have more than one zones, they do, but not every Azure region has more than one zone, right? So in this case, I'm creating a simple application, 2-tier. There's a web front end, and then there is a database, right? Very simple. So in this case, I am creating these 2 copies of this application, and I'm putting them in 2 different fault domains. And the idea is that if one of the fault domains becomes unavailable, my other fault domain is still up and running, right? We talked about this. And I can also leverage things like Oracle RAC, Real Application Cluster, which we actually give you an option. It's not a completely managed rack, but we give you an option to create a managed rack kind of a thing, right? So you do node rack, we give you that option. You could do that, or you could create your own rack. And then the idea is, if you want it to be even more highly available, you could replicate this design in another AD, in another availability domain. And you could use things like data guard to take, the primary and the secondary database, right? So in this case, if the entire availability domain becomes unavailable, this whole thing is unavailable, your application is still up and running. This is what you would do if you have a very highly available application. You want to protect and make sure that it's always up and running, irrespective of what happens to the underlying infrastructure. In case of newer regions, we talked about that the newer regions don't have this capability. So for those regions who have only one availability domain, you stop at the fault domain construct. So you do the same thing we talked earlier. You create a copy of your application across two fault domains. You could use things like Oracle RAC. You could use things like Oracle RAC. But in this case, your fault boundary is your fault domain. So if one of the fault domain becomes unavailable, your application is still up and running. But if, of course, the whole AD becomes unavailable, then you have to do certain other things to make your applications highly available, right? So there's a trade-off, but it's much simpler design this way. All right, so just to summarize what we looked at, availability domain has three fault domains, and they protect against failures within that data center, within that AD. Region, if you have multi-AD region, you can protect. Availability domains give you that protection. If you have three ADs, one AD is unavailable, other two ADs are still up and running. I really didn't talk about this one, but every region we are launching, or every geo we are launching now, we have this concept of a region pair. And what it does, it protects from disaster within, from any kind of disaster, at the same time giving you data residency and compliance ability. So what happens is, every region, let's say India, will have two data centers. So even if one region becomes unavailable, you can still be running in another region. Because if you go back to this picture, what happens if this region is unavailable, right? Because region is one AD, you will have another region here with one AD, and you could do this design across that region, what we talked about in the previous slide, right? So you could do that, and this is what we are going to do. It's just that it's not done right now across the world. So we are, not talking a lot about that, but very soon, as we launch all these regions, you would see this kind of design. And then finally, we have SLAs on availability management and performance. So you can be rest assured that the apps you design, will get those SLA guarantees, and you can read more about SLAs on our website. Now, there is also one concept which is very relevant for people to understand, and that's compartment. Now, it's a OCI construct capability. And think about compartment as a collection of related resources. Why do we use compartments? You will see in a minute why it makes sense. Let's say you get an account with OCI, right? This is your tenancy, this is your account. We also call this as root compartment. This is nothing but your actual account, your tenancy. Within an account, you will have many resources, right? One advantage with cloud is the agility it gives you. You could create networks, you could create databases, you could create compute instances, anything, right? And you could create across the world, not just in one region. That's amazing. In the previous world, the previous time, if you wanted to do that in a data center, it was amazingly difficult. You had to procure hardware and all that, right? I don't have to make that case. So cloud gives you this massive agility, but with the same agility comes challenges. How do you manage your resources, right? How do you do billing? How do you do security across those resources, right? Because people are creating many resources, you have hundreds of users, it becomes really problematic managing so many resources, right? And you hear about these stories on shadow IT, people just bypassing your IT and going straight to the and opening accounts with credit cards and things like that, right? So these problems you keep hearing all the time. So the idea with compartment is, let's say you have many resources, you can categorize them into these things called compartments, which are nothing but logical isolated things. Think about these as isolated buckets, and you can keep your resources in these compartments. And now what you could do is you could do billing on those, you could do security policies on those, and it makes your account much more manageable. So to give you a real example, a company would open an account, and with Oracle they don't need to open hundreds of accounts. Like when I was at AWS, Netflix had 1,000+ accounts, right? Because of course there, it's not just gonna be one account for a company like Netflix. Now they, Amazon has certain things like organizations, etc., to manage that capability, right? In our case we don't need that, because we are coming up with we have a different design. So you open one account with OCI, and then within that account you could create compartments, as many compartments as you want. So you can have a compartment for North America, you could have compartment for EMEA, and within those compartments you can do nesting, so you can have sub compartments. You could do compartments for finance, marketing, sales, whatnot, your departments. You could do compartments for production, development, testing. You could do create compartments like that. The idea is, whichever way you design your compartments, it makes your life simpler, because each of these compartments can have their own billing, they can have their own security policies, and so on and so forth. So it makes it much more manageable. So what are some of these capabilities, right? Keep in mind, each resource belongs to a single compartment. So in the previous picture, your compute, if virtual cloud network goes here, it cannot go to another compartment, it has to belong to one compartment. Resources can interact with resources in different compartments. So again, your virtual cloud network here can have a compute instance which is leveraging the virtual cloud network in a different compartment, quite possible. So everything doesn't have to be belong to one compartment, they can be different compartments. You can delete, add, create anytime, you can move them anytime. Resources from multiple regions can be in the same compartment. So compartment is a global concept. You create a compartment and then you can have resources in every region. Now there are ways to restrict that. If you want a compartment just for North America, you could restrict people that they could only put resources from North America, right? You could do that. But compartment itself are global. They can be nested. They can be 6 levels deep. So you could have North America, and then you could have like departments or whatnot, right? You could actually do that. This is really important. You can give groups of users access to compartments by writing policy. This is the biggest reason why we have compartments. So now you can start doing role-based access control, granular control. You could say that this particular compartment, as you can go back to this slide, belongs to storage admins. Only storage admins can use it. And this compartment, only network admins can use it, right? So then really the power starts showing up. And then the second one, the second biggest reason is you could attach billing to compartment, and you could do things like budgets, you could do things like forecasting. So you could literally pick up a compartment and say how much is the bill for that, right? And you could do forecasting and so forth, right? So remember the two main advantages, obviously to organize and isolate, this one here, and you can give group of users access to specific compartments by that. And then the second one is cost management. And keep in mind that with us, you don't need hundreds of accounts or thousands of accounts. You have one account, create compartments, give each user or group of users access to those compartments, and then you can do things like costing and billing, etc., on the compartment as well, right? So hopefully that 20 minutes or so, 25 minutes, give you a good overview of the core infrastructure, right? The hardware side of things, regions, availability domains, fault domains, compartments, how to create highly available applications. Next half an hour or so, I'm going to quickly run you through the core services. Now again, remember, This is just introduction, so I'm not going at all deep into every service. There are many more features, and you guys should just go and look up more on our free training, etc., to look up like each of the documentation, to look up our the core services, right? So let's start with networking. The networking we have in OCI is called a virtual cloud network. It's a software defined private network that you set up in Oracle Cloud. Why do we do that? Well, a virtual cloud network enables OCI resources such as compute instances to communicate with the internet, other instances, or on-premises data centers. If you don't have a virtual cloud network, your instances cannot communicate. Basically, that's the idea. So you can see here, I have two instances. They are talking to each other. They are talking to the internet, and then one instance is talking to on-premises. This is all done through the software-defined networking called VCN. VCN is a regional service, so it lives in a region. We don't have a global network like Google. It's more like Amazon VPC. So it's a region, and it's highly available, scalable, secure. You don't have to worry about the scalability and the security and all that. We take care of that. So how do we create a VCN? Well, it's very simple to create a VCN. You specify an IP address that is assigned to a VCN. Like you can see here, 10.0.0.0/16. And basically this CIDR block translates to this IP range, something like 65,000 plus IP addresses. Every resource you create in this VCN will get its unique private IP address. So this first compute instance has this particular IP address. The second one is this particular IP address. This address is coming from this particular range here. These IP addresses in a VCN follow the RFC 1918 ranges. RFC 1918 is nothing but a private set of IP addresses which the internet community has created so that we don't run out of IP addresses. So I could use RFC 1918 and somebody else could also use the same RFC 1918, and these are private addresses, right? So these are not routable for the internet. Now when we create a VCN, the VCN itself is not usable just by VCN. So what we do is we create these things called subnet. Subnet lets you divide the VCN into one or more sub networks. And so you could take this big network and you could divide it into these two smaller networks, right? 10.0.1.0/24, 10.0.2.0/24. What is the idea of creating a subnet? Why do we create a subnet? Well, this compute instance and this particular compute instance gets its IP address from these subnets. So every instance you create gets at least one private IP address, and that's it. It doesn't need to have a public IP. It can have more than one private IP and of course more than one public IP. But the whole idea is it has to have a minimum of one private IP, and that comes from the subnet address space. Compute instances are placed in subnets, and then subnets, the whole idea is why you do that is you can isolate them and you can secure them, right? Same concept as what we were talking about in compartments. All right, so let's look at some quick scenarios. And again, this is very basic, very high level. I'm just going to touch about 2 or 3, and there are many more options, right? So to communicate to the internet, we have this construct called internet gateway. Think about this as a massively scalable router sitting on the edge, which is tracking your traffic to the internet, right? So of course, as you can guess, this is a public subnet. This might be a web server. It's communicating to the internet using this thing called internet gateway. Again, every cloud has it: Google, Azure, AWS, same concept, right? You connect to the internet using this gateway. We also have a managed NAT service. So for example, suppose think this particular subnet is private. You have database in here, but you still want to go to the internet to download your patches. How do you do that? Well, we have a managed NAT gateway service that enables outbound connections. So you can go from this instance to the internet and you can download some patches. but nobody could connect to this database from the internet. It blocks inbound connections initiated from the internet. It blocks that. So it's not like a web server, right? It blocks that. So use cases, updating, patching for databases, right? So those are the two mechanisms how you would go to the internet gateway for web servers and NAT gateway for things like database servers. How do you connect to on-premises? Because this is again a very common scenario. Let's say you have a database running here and there's a DNS server here, right? So what you use is called a dynamic routing gateway. Similar to internet gateway and NAT gateway, it's a virtual router sitting on the edge. So you can see it is sitting here. Massively scalable, secure, and it provides a path for private traffic between the VCN and destinations other than the internet. I'm not going to the internet anymore. I'm going to on-premises. So I would use that dynamic routing gateway. There are two concepts you need to understand. We're not going to go deep right now. You could create IPsec site-to-site VPN, virtual private network. Remember, in a VPN, traffic is going through the internet. The idea is it's simpler and it's cheaper, and you encrypt your traffic. But the downside is, your network, you're sharing the internet with everybody else, right? You still are secure. Like you connect I'm sure all of you have VPN, right? You connect your machines to your corporate offices. The second option is we have this thing called Fast Connect. Think about this as your dedicated high occupancy vehicle lane. So your highway has 4 lanes. You get your own highway. This is your private dedicated connectivity, right? This gives you faster speed, but you have to pay more. So these two things can be achieved using this dynamic routing gateway. It lets you create VPN. It lets you create these private connectivity, which is called Fast Connect. So pretty much that is what I just wanted to cover very quickly on networking. What is a virtual cloud network? Well, it's a software-defined network. Lets you connect your instances, let instances talk to each other, talk to the internet, talk to on-premises. And we talked about dynamic routing gateway, one kind of a gateway connecting on-premises. And we talked about internet gateway and NAT gateway. There are many more gateways. There are many more ways to secure. There are things called virtual firewalls, route tables, all that. I'm gonna skip that because again, this is just an introduction. So I'm just sort of introducing you to some of the core concepts. Let's change gear. Let's talk about compute services. This is the gist of running in a public cloud. You are running some kind of compute option, whether it's a container, whether it's a compute instance, virtual machine, bare metal, whatnot, right? So we support a plethora of these options, starting with bare metal, dedicated virtual host, virtual machines, container engine, and functions. Think about this as a continuum. So let's say you are running a bare metal. It's basically, as the name specifies, a physical machine. In this case, you are responsible for the entire stack. So you are responsible for the virtualization. If you want to create, like a KVM, you install a hypervisor here. You are responsible for operating system, and of course, everything which comes on top of that. A dedicated virtual host is basically a bare metal machine we give to you, but it also has a hypervisor running here. So you can create virtual machines on this, and virtual machines you create are managed. So you don't have to install a hypervisor. Why do we do that? Many customers came to us and said that we don't need just a bare metal machine, because you give me a bare metal, that's great, but then I have to install a VMware ESXi, or I have to do my own thing, right? It's a management overhead. Can you give me an option where I can create my virtual machines, but I'm completely isolated from everybody else? This is my box where I run my VMs. Nobody else has access to that. So you guys also hear about these terms called multi-tenant and single tenant. This is my single tenant model. I'm running my VMs. Nobody else is running VMs here. Virtual machine is basically what you're familiar with, every cloud provider, right? This is a multi-tenant model. Your virtual machine might be running with my virtual machine on the same host. It's completely secure, isolated, all that. But still, you and I might be sharing the same tenant. Possible, right? Every cloud does this. We also do that. Then we have a managed Kubernetes service, because everybody has Kubernetes today as a managed service. We also do. It's called container engine, and it's basically as it's a managed Kubernetes offering. So in this case, you're managing your code, you're managing your app container, but that's pretty much it, right? Everything else is managed for you, like the like the clusters and everything. We take care of that, the master node and the worker nodes. And then finally, we have Oracle Functions, which is our serverless offering. So in this case, you are only responsible for the code. You really don't care about the underlying servers. You really don't care about the runtime. We give you a .NET runtime or a Go runtime, and you basically write your code against that. So think about this as a continuum. One extreme end is bare metal, other extreme end is functions. This gives you a bare metal machine where you have the full control, but you have to manage things by yourself. In this case, you get a runtime, so you don't have that much full control, but you also have less things to manage, right? So that's a trade-off. Let's quickly look at some of the couple of more slides on compute, right? Like any cloud, you have different combinations of CPU, RAM, bandwidth. We support both Intel and AMD. We have things like high performance computing, graphical processing unit GPUs, and then instances, as we talked in the previous section, are placed on virtual network, right? And so you can connect to on-prem, you can talk to each other, the instances can talk to each other, they can connect to internet. And compute instances depend on network and block volumes, storage, right? Very similar to every other cloud. So you have an instance here, it's connected to your virtual cloud network using this network interface card, and there is some kind of storage here. We'll talk about this storage subsequently. So how does this work? Well, we create a virtual cloud network as we talked in the previous module or the previous section. We create a subnet. Remember, virtual cloud network by itself is not useful. You need to create a subnet. We create an instance. We put a virtual network interface card within that subnet. You would see sometimes people would put this instance inside the subnet. These are logical concept. Instance is a physical thing. Virtual cloud network is logical. So it doesn't make any sense to put this guy inside the subnet. People do that for simplicity. But what is really happening is you take a physical network interface card here, you virtualize that, and that is part of this network. This is all done in software, right? It's part of this network. And then you have your storage, and we'll talk about block volume, what it is in the next module. But you have your storage, both for your operating system as well for your data. And this is pretty much it. This is how the compute service looks like. And this instance can be a bare metal, it can be a virtual machine, and of course, the Kubernetes thing and the serverless and all are a little bit different. But basically, this is how your compute instance looks like. Depends on the network, depends on the storage. All right, so that hopefully gave you a quick 2-3 slides intro on the different options we have, what virtual machines are, and how they work in OCI. Let's look at storage services. So starting with, we have block volume, we have local NVMe, we have file storage, we have object storage, and archive storage. This is again very similar to other cloud providers. Let's look into each of them in more details. What is block volume service? We talked about this in the previous section, right? So you have an instance here, you have a boot, you have instance depends on your block volumes. Think about this as storage for your compute instance. You have a computer like your laptop, your desktop. It has a hard disk. Think about the same concept. You have an instance running here, the hard disk is here. Why is it called block volume? It's called block volume because the data is managed as blocks of data, right? It's people coming from the SAN background on premises are familiar. Data is managed as fixed number of blocks, so that's why it's called block volume. There are two kinds of block volumes: boot volume and block volume. These are all again the same underlying service. We have just created a different class for some things, but for your consideration, consider one is where you keep your operating system disk, your instance boots up from that, and the other is where you keep your data disks. What is the biggest reason why we are using block volume? The biggest reason why we are using block volume is it lets you store data independently and beyond the lifespan of compute instance. So if this compute instance becomes unavailable, your block volume is still up and running, is still preserved. The idea in a cloud is everything fails all the time. So if this instance fails here, you don't want to lose your data. And that is why you use block volume. It lets you store data independently and beyond the lifespan of compute instances. What are the use cases for block volume? Well, databases will run on block here. Some of these other applications like Exchange supports block storage only. VMware actually leverages block in a big way. And then, of course, like we talked about, the server boot, your operating system are always configured to boot from block level storage most of the time in public cloud space. All right. There's also another kind of block volume which is called local NVMe. Now this is block, but it's directly attached, locally attached to the compute instance. So think about this as directly attached storage. So if the previous block volume is analogous to storage area network SAN, local NVMe is similar to DAS, directly attached storage. Why do we do that? Having your storage directly attached to the instance gives you very high performance, millions of IOPS. So what are the use cases? If you're running things like NoSQL databases, this is a fantastic use case because you require thousands of millions of IOPS, and this local NVMe can actually give you that. But the downside is the storage is non-persistent, meaning that if my instance is unavailable, my storage also is unavailable. So keep that in mind. Trade-off is it gives me higher performance. Downside is data is not persistent like block volume. The third kind of offering we have is file storage. The idea is it's a shared file system for compute instances, right? So again, coming from on-premises environment, think about this as your network attached storage, NAS. So it's a shared file system for your compute instances, and there are many applications which actually depend on it. So like EBS, if you want to use EBS, it has a dependency on using a shared file system, right? So it requires that. High performance computing actually does leverage this shared file system, and so on and so forth. Today we support NFS v3. We don't support v4 yet, and we don't support SMB, server message block. We only support network file storage, NFS v3. And we have several capabilities, right? Like block volume, we can take backups, which are called snapshots, and we have security, for data encryption at rest, data encryption in motion. I didn't really talk about a lot of these features for block or file, but it has a lot of security features, a lot of backup restore features, lots of features. The final two storage offerings we have are object storage and file storage. Object storage, again, as the name specify, is, or as you guys might be familiar with, Amazon or Google, is this is an internet scale high performance storage platform. It's ideal for storing lots of unstructured data. So if you have images, you have media files, you have logs, you have backups, you would store them in an object storage. It's a regional service. It's not tied to any compute instance, so it's different than file or block. You don't actually use it with an instance. It's basically using your HTTP works. So put object, get object. It's a completely different way to think about storage. You are using storage for the web, right? So what are the use cases? It's like I said, it's a storage for the web. So you can use it for content repo, storing your data. You could use it for storing your backups. You can use it for storing your log, analytics, those kind of things, right? There are two classes we have for object storage. One class is called hot tier. This is basically fast, immediate, frequent access. So you store data, you retrieve data. as is instantaneous. And this basically is what you are frequently familiar with, right? Using object storage like S3 to store whatever data you want. You can store that in the cloud. Now this data is immutable, meaning you cannot change it. So you store a copy. You can store multiple copies when you change it, and there are things like versioning and life cycle management, etc. But basically, you store a copy of the data, right? You don't change it. You don't modify it. The second type of object storage is, in our case, called cold storage or archive storage. This is for backups. So if you have long-term backups where you want to keep your data for long terms, and you don't really need them to access frequently, you could use this backup, right? So the idea here is you are replacing tape backups with something like archive storage. Why would you use it? Well, it is 10 times cheaper than the standard storage, right? You can look some of the cost there, and then but with that comes some of the trade-offs. There's a 90-day minimum retention requirement, and there is a time before you can download your first bytes. There's a minimum 4-hour time period, and again there's a trade-off because you are getting a storage which is 10 times cheaper. So you have some trade-offs. You have to keep the data for 90 days, etc. Right? This is again very similar. This is like Amazon Glacier, very similar to if you are familiar with other clouds. You have a standard object storage, and then you have an archival storage. So that's pretty much everything on storage, at least from a very high level. I really didn't talk about a lot of features in any of these categories, but they all have backup capabilities, restore capabilities, security, encryption. Object storage has things like lifecycle management, replication. Same thing with block volume. You could do cross-region replication. So there are lots of features, right, in each of these. I'm again very touching them from a high level, the use case perspective. So now change gear. We talked about networking. We talked about compute. Let's talk about database, because this and the last topic, identity, are the core topics you need to understand when it comes to any infrastructure platform. So from a database perspective, we have different options, like we have with storage, compute, networking, like we saw to you. So the first option is we have a managed VM DB system. So in this case, you are running Oracle database, as you can guess, on a virtual machine. We have, the advantage here is you can provision it very quickly. We have a bare metal DB system where you're provisioning an Oracle database on a bare metal machine, right? The advantage here is you get really fast performance. We have a rack offering where you are doing this across 2 different servers or 2 different VMs, and the idea is you get a real application cluster, a managed high availability, right? So instead of doing it yourself, it is managed for you, and we do the underlying, we set up the cluster, we set up the file system, all that stuff, right? We have an Exadata DB system. This is in fact one of the most popular offerings, right? So Exadata, people who are familiar with running on premises, now you can get that in cloud, and it's basically managed Exadata infrastructure. And then we have autonomous, and autonomous has 2 flavors. One is shared. So think about this as a shared multi-tenant model where your database might be running on an infrastructure with somebody else's database. Again, all secure and isolated, but shared multi-tenant model. And the other model is dedicated, where your database is running on your dedicated Exadata infrastructure. The idea with autonomous, which I'm sure all of you guys are familiar with, is it's self-securing and self-repairing, meaning we take care of a lot of things which otherwise your DBS would be doing, right? So things like tuning, things like patch management, etc., etc., right? All that is taken care by Oracle. This table here is by no means complete. Actually, I have a very long spreadsheet which has 100 rows or so. But for this discussion and just from a high level perspective, it just shows you some of the differences, right? So let me just highlight a couple of the main ones, right? So you can see, some of the updates for the virtual machine systems. The bare metal customer has to do it. For autonomous, some of that is automatic. In case of scaling, Exadata actually gives you the best scale. Exadata gives you better scaling options than VMDB and bare metal. But autonomous, you can scale both CPU and storage. You can see some of the backup options here. In case of autonomous, again, it's automated. For others, you have to do it yourself. You can look up the storage. You can look up real application cluster, which are available, and data guard, and so on and so forth, right? This is just a subset of the capabilities you get. And I'm sure a bunch of you guys are more familiar with Oracle, so you know a lot of more details here, right? Finally, let us talk about identity and access management. And in a nutshell, IAM basically says who can access what resources, and that's pretty much it. It's role-based access control. You decide who are the people, group of people, or applications, and what kind of resources they can access. And that's basically your identity and access management, right? So the two concepts which come here are authentication and authorization. Authentication basically deals with user identity. Is the user the one who he or she says he or she is, right? And how do you authenticate? There are three ways to authenticate in OCI. You do it by username password, right? Very simple. You go to Facebook, Google, Gmail, you authenticate, you prove your username password. You do that with any cloud. The second one is API signing keys. When your APIs are making calls, they have to sign and say who they are. Otherwise, the system doesn't know who these APIs are or who is using these APIs. And then the third one is this concept of called authorization tokens. This is particularly relevant for third-party APIs which do not support OCI signature-based authentication. So if they don't use this API signing keys, but there are third-party APIs which want to leverage OCI, there is an option called authentication token. This is very relevant for things like autonomous database, right? Like ADW has its own set of APIs. For it to access, let's say, OCI object storage, it uses that using these auth tokens. Says that I'm authenticated and I can use OCI object storage. Similarly, authorization basically it deals with what kind of actions you can perform. Once you authenticate someone, what can they do, right? In case of OCI, authorization is done with these things called policies. And you write these policies in a very human readable format. You say allow, by default, everything is a deny. So you say allow group to do something, and the group can be a group name, a group of users, and they can do something on some resources, perform some actions on some resources, right? So what does it look like? Well, this is the syntax, and it's actually pretty straightforward. This subject is your group. So you have a group of users, let's say your storage administrators or network administrators, and you give them some kind of access. And the access, you have 4 levels of access, starting with inspect, where they can only inspect resources; read, where they can read resources; use, where they can update resources; and manage, where they can manage everything. And then resources, like you can guess, are your actual resources. So you could tell them to manage every resource. You could say all dash resources, or you could say, bunch of these resources here in a very granular way. You could restrict them to only using database, or only using instances, or only using objects. So let us look this look at this in a real example, right? So in the previous one, we talked about this availability domain and region and a compute instance, right? So we have the same design. You have a network here, subnet here, compute instance, and you have your block storage here, right? Now this can be in a compartment, and the compartment is called ABC here, and then the virtual network is in, let's say, in the root tenancy, right? So you have different admins for each of these areas, right? Because the whole idea of identity access management is to isolate resources and give specific users access to those resources. The network admins manage a cloud network, so you can write a policy like that. So they manage virtual network family in the tenancy in the entire network, right? There are compute users who are launching compute instances. So these users, you could give them, write a policy where they can manage instance family in compartment ABC. So they are only restricted to this particular compartment ABC, but they can manage compute instances, meaning they can create, they can read, they can update, and they can delete the CRUD operations. They could do that. But these guys cannot create block storage, or they cannot create virtual networks, right? Because the storage admins are creating this block storage, and the network admins are creating the network resources. So for the policies you would write here is these guys can use volume family, meaning they can update and of course read, but they cannot delete. And they would use virtual network family, meaning again they can update, they cannot delete those resources or create those resources, right? So you would write a policy like this, and literally this is the set of policies you need for this setup to work. Well, so in a summary, we looked at OCI regions, availability domains, fault domains, the hardware part of OCI. We looked at what ADs are. We looked at what fault domains are. We looked at compartments, which is a very important concept, basically to give you logical isolation and for costing and billing purposes. And then we went over the core IS services. Starting with networking, we looked at the different options, and again, very high level, virtual cloud network, software defined network. We looked at compute, the 5 flavors: bare metal, dedicated virtual host, virtual machines, container engine, serverless. We didn't go deep at all in each of those, but we looked at a high level. We looked at storage, block storage, NVMe storage, file storage, object storage, archive storage. We looked at database, virtual machine, bare metal, rack, Exadata, autonomous, and 2 flavors of autonomous. And then we looked at very high level from identity perspective, right? Authentication, authorization. How would you really design a simple, compute instance running in a virtual network and using block volume? So with that, let me stop here. I see I'm just running over by a minute or a couple of minutes, and I don't know you guys do generally Q&A or not, but I hope this was useful. I'm happy to answer if you guys have any questions or anything.
Thank you, Rohit. Thank you for this detailed session, and we have around 10 to 15 minutes of Q&A. So guys, if you have any questions, can you paste it on the chat window? Are the student guide available for also? I don't think Mayur has asked that. Student asks for the student guide, and I think the student guide is not available for the OCI free trainings.
Well, I'm just going to write a blog post in a couple of days where I would actually give links to that. So next week it will be available. I'll send you guys a link once I'm done. But yes, today it is not available on the site yet.
Okay. So Basant has asked, can you explain when you say instance is physical, what actually that means? Instance is basically set of memory plus background process. I guess Basant is confused with the database instance and is it?
Yeah, physical basically means you are giving access to the physical machine, right? So you have like the physical machine, which is basically your like your data center. You get a physical machine like a server, right? So we give you that. That's a bare metal machine, and you have access to it. Like you can do whatever you want. You would do with a physical bare metal machine. You have complete control over that. Same concept, but in a cloud environment.
And one of our attendees, Mahesh, has asked, in free tier, can we test any services?
Yeah, free tier gives you access to, if you go online and search, free tier gives you, if I'm not mistaken, 8 cores. It gives you autonomous database, it gives you block volume, storage, everything, right? So load balancer. So yeah, you can actually go test your services, absolutely.
And Tanvir has asked, what is the main purpose of creating Credential Store?
Purpose of creating what?
Credential Store. I think it's a very new.
Credential Store. I don't know what exactly you mean by Credential Store. Well, I mean, any credential is done for authentication, right? So if you mean the auth token, the whole idea of an auth token is to, authenticate your users or your applications, right? So that's the reason why we create that.
Okay, Ravi has asked block volume is shareable or not with different instance. Can we share the block volume to different instance?
Yeah, there is a new feature called multi-attach block volume. So what that does is, I didn't really talk about that, but like in the previous, uh, like I had here. So in this case, you can have a multi-attach block volume here, where multiple instances can share the same block volume, and you can read online. You can go and read online more on what it looks like. Uh, One instance can write, other can read any given time. Multiple instances cannot write to that block volume, but you can read more on that. But yes, that feature is supported. It's called multi-attach block volumes.
And Basant, I will reply regarding the OCI course. And yes, the OCI course that is available free is sufficient for the mentioned certificates. Means if you go through the all the videos, then you can easily pass the certificates.
Yeah,
And
that's correct.
and Dibesh, yeah, just ping us. We will provide you the detail regarding how we can register for OCI free course. And Manish has asked that I created database with a data guard, but there is not option to connect data guard using PuTTY. Is that true?
That I have no idea. Why don't you send me an email and I can
Mhm.
ask somebody who works for me, I can ask him that. I really don't know.
Hi,
I think we
hi,
can.
Rai. Good morning. This is Manish. Actually, I have another question regarding data guard.
Mhm.
I found there is the failover option, but there is not a switchover option. Can you put light on it?
So the both options should be there, failover and switchover. When you say it's not there, meaning where? Did you see in the console or where?
Yeah, I checked through console and found there is only one option that is failover.
Okay, should be there. Why don't you take a screenshot, send it to me? I'll get it to the guy who runs that, and he can answer it. But yes, both options should be there. Yeah,
Okay, thanks.
yeah. I don't have a slide on that, but yes, it's there. Both should be there.
And Mayur has asked, can you please explain manage rack?
Well, in case of managed rack, what happens is, we create a two-node virtual machine rack. So these two nodes are running on virtual machines, right? So you
Mhm.
cannot create a 4-node or a 16-node rack in the cloud. It's always a 2-node. And what
Mhm.
we do is we create the underlying clusters. So we create the storage cluster, we create the interconnect here, and you basically come and you specify that I need a 2-node rack, and that's pretty much it, right? And we created everything underlying, and then you can create your applications. You leverage the rack here. So that's basically what we do by managed. Um, and keep in mind it's only limited to virtual machine. And again, if you go on the documentation, you can read more about that.
Okay, Malik has asked that is this PPT available? So Rohit, are you going to share this PPT
I'll
with us?
send it to you after the call. Yeah.
Yeah, thank you. And Robbie has asked, is block volume? Yeah, this is already replied. Can we configure rack and data guard with a free access OCI account?
I don't think so. Check again, go on the website and check the limits and everything. But I don't think you have rack and data card available there. I don't think.
Okay, guys, we are done with the Q&A. And if you have any question left, just paste it on the chat window. We will share it with Rohit, and Rohit will reply it back. Is it fine,
Fantastic.
Rohit?
Yeah, I'll definitely do that. Yeah, and I'll send you the deck.
Okay, thank you.
All
Okay,
right,
Rohit.
cool, fantastic. Thanks, guys. Stay safe. Stay home.
Yeah, you too. Thank you,
Thank you,
Rohit.
Rohit. Thank you. Thank
Okay,
you so
thanks,
much.
guys. Thanks, bye.
Take care.
Thank
Thank
you.
you. Bye.
Okay,
Thank you.
bye.
Man.
Thanks.
Bye.